Hello everyone, we'll just get started. I'm Anthony Baxter. I used to be the release manager for Python, then I got a job at Google and that ate all my free time. Unlike me, these guys have actually, continued contributing to Python. I just sort of sit in the background and occasionally throw rocks. I might introduce our panel to get started. I'll ask them each to sort of give a brief word about themselves and also pick a couple of things they're most proud of having contributed to Python. So we'll start off with Nick. Speak into the mic, Nick.
CPython core dev. Probably the thing I'm most proud of is being co-author of the PEP that added the with statement to the language.
Fantastic.
Did you actually write the patch as well?
No. Reviewed it.
Yep.
Raymond Hettinger, I'm one of the Python core developers also. He asked me to pick a couple things I'm proud of. Code-wise, I brought you generator expressions. Hope you like those. And lots of collections, thingies, sets, decks, ordered dict, that sort of thing. But outside of code, I've done a couple things that I was fairly pleased with. In Python 3.3 or 3.2, if you go to the documentation now at the top for every module, you can click on a link to the source code so that instead of just reading a description of what the code does, you can actually go right to the piece of code. And it is my goal that people start using the reading the source code a lot more than they have been. But my best contribution so far took very little effort. Many years ago, there was a person going by a pseudonym who wanted to contribute to the Python core. He had Asperger's and said that he was having some very bad interactions with the other core developers. So I decided to coach this person through his first set of patches, and next thing I know, he's going by his real name and has contributed more code than all of the rest of us up here combined. So my best accomplishment ever was Georg Brandl.
And completely rewrote the DOS system.
Yeah, so it turns out your best contributions aren't necessarily code. It can be just networking people and mentoring.
Awesome.
And Richard on the end.
Okay, so I'm Richard Jones. On paper, I'm a core developer of Python. I have commit privileges, but I don't use them very often. My biggest contribution would have been the rewrite of the exceptions object system, which is the current implementation. Since then, I think I implemented something to help unit test socket module stuff, but beyond that, not much else.
Well, and the package index.
I did, on the other hand, implement the Python package index, the cheese shop, and also Roundup, which is used as the bug tracker. So mostly I'm kind of in the tools side of thing.
I think we'd all agree with that.
Thank you,
Anthony. We'll start the Python 3 thing with the why would we bother? I mean, really, 2.4 is probably good enough for most people. Why would we bother?
It doesn't have with statements.
Okay, so 2.7 then. What major advantages do people get from actually making the effort to port to Python 3?
The big one is Unicode, is that Unicode Strings, but if not for that, I don't think Python 3 would have happened. But it's basically having the core string type be Unicode based is just a recognition of the increasing globalization of programming and everything. So. Yeah,
I guess. What does that actually buy people if they're sort of started? I mean, why would people care that the strings are now taking twice as much RAM as they used to?
With 4 times as much.
4 times.
I'm thinking of a good answer to that.
One of the interesting things you'd see with a lot of Python 2 programs, particularly those written by native English speakers, is they'll work fine so long as you're in an all ASCII environment. As soon as you introduce any kind of foreign language, their application will either fall over, or worse, it'll produce garbage output without crashing. And the switch to Unicode by default there's a reason developers hate it, which is that they're forced to deal with those issues straight away. But ultimately for end users, it's better because the programs are actually far more likely to deal with non-English input correctly.
So, one of the points of Python 3 was that it was cleaning up a whole bunch of stuff. And the way that strings, we had strings and Unicode strings in Python 2 was very messy and very confusing. It's now much clearer that the stuff you get out of a file is bytes, and you turn that into a string to do string work with it. And that's much clearer and more explicit, and I think that's a real benefit of using Python 3.
Any other thoughts as to other things people
Along
do?
the lines of cleanup, over the years, Python accumulated amount of cruft. We would find new ways to do things that were better, and one of our principles is to have preferably one way to do things. But then we ended up with old style classes and new style classes, and so we had many ways to do it. And our one chance to clean all of that up was to transition to Python 3. So if you're teaching anybody Python, or if someone's coming to the language new, it is much easier for them to learn Python 3 than it is to learn Python 2. You don't have to learn about range and X-range. There's just range that happens to do the right thing and handles its limits better so that you can put in very large range limits, and you don't have to switch modes between short integers and long integers. There are lots of little pieces of knowledge of things that we had to learn the hard way over the years that no longer, people don't have to learn anymore. Python will just work right out of the box. And I also wanted to address, you asked me something I couldn't answer right away, which is why do our applications need to be Unicode aware? And it's not just so that later you can internationalize your apps, because a lot of people write apps that don't need to be internationalized. Out of the world, the context that Python is running in, the world is changing around us, and you will find that your operating systems now are much more Unicode aware. Every other tool you interact with is Unicode aware. People will cut and paste code snippets in, and Unicode will introduce itself. You think, well, I'm not working with Chinese, but some quote marks came in that were not in the ASCII range, and that sort of thing. And your program would tend to fall over dead, written in an old style, and it will just naturally accommodate all pieces of text equally well under Python 3. And so it's almost something that we couldn't neglect, because the world will have changed around us, and the world will insist on the JSON spec requires UTF-8.
By the way, if anyone's got questions, particularly if they're related to what we're sort of going through, feel free to put your hand up. Ryan's got a mic there. So does anyone have any sort of comments on that sort of stuff? Any? Yep.
You can throw tomatoes if you want.
Yeah. At them, not me. Yeah. Okay.
Just sort of related to that, in a couple of months I'm teaching a beginner's workshop. As of now, do we go 2x or 3x, and why? Are you ready, I guess? Is it...
If I might. I actually have, for the last few years, I've lectured Python at RMIT in Melbourne. And next year I'm going to transition to teaching Python 3. Up till now I've taught Python 2 with a little Python 3 caveat at the end. And I'm going to be switching to teaching Python 3 with a Python 2 caveat at the end. So if you have to do Python 2, then these are the things you might have to look out for. But I think that given the amount of migration that's happening and the speed of migration, I think it's reasonable for people to start programming Python 3 now.
One of the other interesting things is that programming in Python 2.7, clean 2.7 code actually looks an awful lot like Python 3 code. The only major things that are different is there's a few syntactic differences to do with the way print works, which you can bring in with the from future import anyway. And so, yeah, I guess with the future imports, you can make your 2.7 code look almost exactly like Python 3. And so the main thing people have to pick up in going back and reading 2.x code is learning some of the old stuff that other people will have written, even if they're not writing it that way themselves. But yeah, it's definitely getting to that point where it's reasonable to teach people Python 3 as the first step.
So, like Nick, when I teach, I try and teach the intersection knowledge, that which applies to both. That being said, you kind of have to adapt to your audience. If they are working in any kind of environment where they're required to be using Python 2, you almost have to teach to that. Otherwise, you'll teach them a set of skills and they won't be functional in the environment we're working in. State of the world right now is it is converging very much on Python 2.7. It is our long-term maintenance release. We will maintain it for years. So I recommend everybody convert to 2.7 right away, because you won't have to migrate again a long time until you go to Python 3 years from now, and we have porting tools to help you get there. What's converting on 2.7? Well, if you pull down a commercial release from InThought or from ActiveState, it's at 2.7. App Engine will be at 2.7 very shortly. PyPy is 2.7. The
IronPython's 2.7.
IronPython and Jython has a mix of features, so you can get the best of both. So if I'm teaching people who don't have a whole bunch of library needs and aren't going to have dependencies in 2.7, it's really nice to start with 3. But the reality is, as soon as I touch the corporate world or any business that's heavily invested in Python, they're in the 2.7 world, and they won't be migrating anytime soon.
So following on from that, what is the biggest pain point for people when they're actually going from 2.x to 3.x? Where's the bit that people fall over and get hurt?
Bytes and text.
Bytes and text?
Yes. So when I'm teaching class, I now have this little half an hour spiel on, at some point you have to wrap your arms around Unicode and learn it one time in your life. Just Python 3 forces you to know it. And in Python 2, you can write many, many useful programs and never use .encode and .decode. I don't think it's possible to write much in the way of meaningful Python 3 code without having to do a whole lot of encode and decode. Just to take the MD5 checksum of a string now requires that knowledge. It is now fundamental day one knowledge. You can't do anything useful without it. So it's not so much a stumbling block, it's just something that you have to know. And once you know, it's good. It's not that hard to learn.
Is that also the case with porting older code over,
Absolutely.
even with the tools?
Yeah.
Absolutely.
So the interesting thing about the bytes Unicode change is that if you have your bytes Unicode split correct in your Python 2 code, the tools will probably do a pretty good job of helping you migrate. However, one of the biggest problems with Python 2 is that the boundary between what's binary data stored as an 8-bit string and what's actual text stored as an 8-bit string is not clear to the interpreter at all, and often it's because the program itself blurs the boundary. And what Python 3 forces you to do is you have to split. You have to say, right, at this point I'm dealing with binary data, I'll make it bytes. At this point it's really text, I'll make it text, and I'll use encodings to get between the two. But you have to make that distinction or your program just won't work. It'll generate rubbish.
So it sounds like you've just gone back to with Windows having binary files and text files, really, doesn't it?
Well, the binary the binary versus text files distinction actually matters on Unix platforms now, because if you open a file in binary mode in Python 3, it'll give you raw bytes. Input will be bytes, output will be bytes. You'll get raw binary data out of it. As soon as you open the file in text mode, the language I/O stack will put an encoding layer on top of the binary file, and it will actually read and write text and will transparently encode it for you. But that distinction now exists on both Windows and on POSIX systems. And so a lot of POSIX programs that previously didn't care and may not have flagged the fact that they wanted bytes, they'll actually break on migration to Python 3 because they'll have this encoding layer that they don't actually want because they're really wanting to manipulate the raw bytes of the file.
So how many people in the audience have actually had to deal with Unicode in their Python coding? Okay, so it's about half. How many of you actually found it problematic at the start, at least? About the same number. So, okay, following on from that, how many people have actually done Python 3? Used the Python 3 stuff at all? I should have asked that at the start. Okay. Raymond apparently hasn't.
I nodded.
I'd like to just point something out. There's this awesome book, Porting to Python 3, and it actually has a section on the common migration problems, and the bytes, strings, and Unicode section is by far the largest. But it does.
I didn't say there was an open book test.
But it does. This is a great book, and it really does cover all of the various issues around moving from 2 to 3 and backwards again, really, really well. And it's that big. It's thin.
Does this one also?
I don't actually know. I haven't opened one of those up.
Okay, well, we've got these, by the way, as 3 for people asking good questions. So,
Ask good questions.
anyone there yet? Yeah. Oh, suddenly they're all. Oh, there's
We're not
free
saying
stuff.
that the first question wasn't good.
Yeah, no, the first question was good.
Okay.
Yeah.
Do you still want to make it?
Oh.
I'm not sure exactly which version of BuildBot we're running at work, but that's also not UTF compliant because I managed to break it about a couple of weeks ago by putting in a branch called star in Git. And Git was quite happy, like
Star?
Unicode 2605.
Oh, okay.
So-
By the way, if you want to ever break something that's Unicode aware or claims to be, use the musical symbols because they're above 2 to the 16. So all these people assume they can fit a Unicode thing in a 16-bit, and it's actually 21 bits. It breaks pretty much everything.
That's fantastic.
So you're saying there's problems with BuildBot itself?
Yeah.
Yes.
Do you want to just bring up the Pi3K porting
The Pi3K.
tab window?
The
No?
app spot.
Just tell me what it is, and I'll.
Yeah. That's not going to
No trust. Apparently, gingers just have no trust. Yeah.
Hi, just a question about porting C extensions.
Yep.
I'm particularly interested in a library called OmniOrg.py, which is a fairly complex C
they've called
extension.
the thing, yeah.
But I'm interested in, do you think that a C extension should be forked for Python 3, or should an attempt be made to make the C code compile with both?
I'm trying to remember where the resources are. I think there's a how-to on python.org with some tips.
Yeah, that how-to refers to some backwards compatibility macros, which have been removed in 3.1.
Yeah. Or been removed in 3.1. C extensions are definitely quite a bit harder than the ordinary stuff.
Really good section in the book about C extensions.
Oh, there you
You want
go.
to think? Are you getting?
No, I'm just saying, it's a really thin book. There's not a lot to talk about. It's not that hard.
And Leonard's actually put the whole thing online as
It's
well,
free.
if you want to have a quick look at it. So, but yes, so I defer to Leonard's.
Was there some sort of lib2 to 3 for C extensions?
Yes. Somebody has written something.
I think someone's been working on one. I've got no
I would
idea.
be shocked if
what's
it worked. I mean, we no longer have distinct int objects and long objects, for example. So you can't inspect inside the object anymore. So the C object model just for numbers has changed. The C object model for any time you interact with text, everywhere in your C code that you use double quotes, you're sending in a regular string into a Unicode aware world, and there needs to be some buffering between that and the rest of the world. I don't think it's that trivial. I think it requires a human eye to switch over. The distinctions between Python 2 and 3 at the C level are far more profound than they are at the user level.
What's the library 6 supposed to do? I understand it was adjusted to like C extensions and
Sorry, can you say that again?
the library called 6, SIX.
Yep. So what 6 is about is there are a few things that either change names or you can do version checks to say, for instance, map in Python 3 is itatools.imap in Python 2. And so what 6 will do is it'll just hide that kind of thing for you. You just do from 6 import map.
The idea being that you can write code that's compatible with both 2 and 3.
And then 6 takes care of the version switching to get the code from different places.
Hi. I just have 2 questions about concurrency. First thing is, are there any changes to the guild?
Are you going to ask the 2 questions at the same time?
Yes, Python 3.2 does have a different GIL implementation. The 2.x and 3.1 GILs were tick-based, so they were based on the number of bytecode instructions executed as deciding when to yield, or when to allow preemption. The 3.2 GIL instead is time-based, so that even a long-running C instruction may still, when it gets back to the interpreter loop, it'll release the GIL straight away, whereas historically it had...
Does this actually also address the stuff that David Beasley found?
It's as a result of David Beasley's
moves
post,
it around.
However, David would say it does not yet solve the problem. It solves old problems, it creates new problems. So almost certainly the GIL will go through additional iterations.
So that's actually, if you're interested in what I was talking about there, David Beasley has a video up on YouTube, I think it is, it might be on Vimeo, I can't remember, one of the videos hosting sites, about sort of various issues he discovered in the Python GIL. It's quite an exercise in amazing forensic sort of computer science in that, you know, eventually he's disassembling or looking at the source code for the threads library on his operating system. And it's a quite fascinating sort of, as I say, exercise in sort of really hardcore forensic sort of computer science to sort of figure out what exactly was going wrong and why. I think the original problem was that a multi-threaded program ran faster on his MacBook if he turned off one processor. You know, and it's that sort of thing where it's actually, you know, you know, for all the GIL is in theory simpler. This is one of the things that I don't think that change got put into 2.7, did it?
No. So this is all purely Python.
There's another
stuff.
possible reason for Python 3 is that, you know, the future nice shiny stuff
yes.
is going to be not going back into 2.7.
Concurrent.futures, I think, is... I think Google have backported it to 2.7 for App Engine.
Yeah.
But,
well, 2.6 at the moment, I think.
Okay.
Yeah. 2.5, sorry. I think
2.5,
yeah.
But, yeah, the mainline version of that is only in 3.2.
It should be. If it's not, I can beat up Brian Quinlan and get him to release it because he's one of our co-workers who actually wrote the PEP for the concurrent.futures. Okay, so
The second question?
supposed to ask them at the same time.
What about the multiprocess module? And you know, are there any changes? What is the future of the multiprocess module going to be like?
It needs love. The original creator of it has passed away. The person who has initially maintained it in Python is working on many other things, very large projects, and there are many open bugs on multiprocessing, and we're getting a lot of new core developers, but they're for the most part they don't have the skill level to tackle this level of problems. So we need people like the kind of folks who are in this room to volunteer their time to roll up their sleeves and make multiprocessing wonderful. Right now, it's not getting love from people with sufficient skill level to make comprehensive, correct solutions to the problems that are there. Is that a fair?
Yeah, so Jesse's the current maintainer, but as Raymond said, he's got a lot on his plate.
He's running PyCon next year, has children, a startup.
Yeah, so he...
Possibly, if that's the sort of thing, it's interesting, hang around for the sprint, and I'm sure Nick and Raymond, do you hang around for the sprint as well, or? No? Okay, well, Nick at least can point you at sort of some of the...
I'll have to dig
from memory, there are various levels of sophistication required in the bug fixes. Right. Some are easier than others.
Yeah, and something I want to touch before we move on was, we mentioned the 6 as a tool for bridging the gap between 2 and 3. There's one other interesting strategy that emerged. The original plan was you would write Python 2 code, there was a converter 2 to 3, you'd maintain the code in Python 2, always run the converter to make your updates so that you could have simultaneous versions. What is interesting is that there is a 3 to 2 tool now that goes backwards, and it turns out it's easier to write correct 3 code that can easily be correctly translated back to 2 than it is to go the other direction. And I thought everybody should know that is, I think, now a preferred strategy and a best practice as opposed to using 2 to 3, which is our original plan.
I think the one weakness is that 3 to 2 itself isn't quite as mature as 2 to 3.
Right.
But yeah, it's certainly an interesting
conceptually option. Yeah, were it as mature conceptually, you're much better off writing 3 code that's simple and clear, because we can get from that back to 2 more easily than going from 2 to 3. There's a lot of places where you have to do either need to humanize, make guesswork, or that sort of thing to figure out what is the corresponding meaning in 3. But when you go 3 to 2, there's no guessing on the semantic differences.
Well, that's more or less the answer to my question. I was going to ask from the
Time machine rocks.
from the perspective of a package maintainer whose biggest audience is going to still be 2.7, how should they be thinking about supporting 2.3?
Yep, so Distribute has a flag called use 2 to 3, and it's basically designed to do the forward port option where you write 2.x, and then as part of the install process, it'll generate the Python 3 code. The thing you've got to be careful of with that is make sure you run your test suite on both versions, because otherwise you're going to be generating something that you haven't tested, which your end users may not be happy with you.
You guys use Tox at all for doing cross-version
I've heard of
testing?
it, I've never used it.
Same here.
It's great.
What is it, sorry?
A project called Tox, which is basically a wrapper around virtual env, that if you've got your test suite set up to run...
The wrapper's all the way down.
The wrapper's all the way down. It will basically, if you've got whatever versions of Python you've got installed, Tox will run your tests against all of them. So it creates a Python 3.2 virtual env and runs your test in that, creates a 2.7 virtual env and runs your test in that, all from a single command. So if you've got your package set up, if you've got Distribute plugged in with its 2 to 3 flag switched on, you can just run Tox and you just check 2.5 check, 6 check, 3.2 check in one command.
Can I overthrow you for just a moment and suggest, so that we don't run out of time, one of the things you'd ask us about was things that are new in 3.3, if you would like to.
I was about to ask that. It was more about asking what should people look forward to in the 3?
In 3 in general, or are you talking
3.3 and onwards, yeah.
Okay. So something I think is really wonderful is in 3.3 now. I'd say in the collections module, it's called chain map. And the idea is if you have 2 different dictionaries, you can link them together to act as if they were one. So a lookup into the chain map dictionary will look in the first dictionary. If it finds a hit, it returns the value that it found. If it misses, it'll then go on and look at the next dictionary, and it can do many in sequence. And what's fantastic is the number of things that you can model with it. So through hand waving, I will describe what it does. You're teaching a Python class and you talk about how the scopes work. You say, well, first we look in the local scope, which you can access through the locals built in. Locals will give you the dictionary. If value is not found there, it will look in globals. So that's another dictionary. And if the word is not found in globals, it will go back and look in the built-ins dictionary for all of the built-in methods. That can be modeled with chain map, locals, globals, built-ins. And so it'll construct that lookup process for you, meaning you can interject new namespaces into that search or rearrange the order of the search. Another very common thing to do is to say, I have a set of default parameters, configuration parameters for my program and stored in a dictionary. In addition, I'd like the user to be able to specify some defaults in their operating environment, which we can access through OS Environ, which is a dictionary. In addition, I'd like them to be able to override those through command line arguments. Argparse returns a namespace argument, which is a dictionary. You wrap vars around it and it becomes a dictionary. So how can you look in those 3 namespaces all at once? You chain map vars of the namespace from argparse, followed by OS environment, followed by your default configuration. One line gives you that that lookup and the prioritization between the 2. If you're familiar with Lisp, you know that there is, in addition to static scoping, there's other styles of scoping, like a dynamic scoping, to where every function inherits the scope of whatever function called it. That's very easy to model with this. And so it beats the heck out of the old style of, we take a dictionary, we make a copy of it, and then we do an update based on another dictionary and an update based on another dictionary. And those are very slow, and they don't give you dynamic views. They don't update as the underlying dictionaries change. So you get all that for free with chain map in Python 3.3. And if you look under the covers in Python 3.2, chain map is already there. It's just called _ chain map because we didn't want to introduce a new API. So it's just sitting there waiting to be used.
So perhaps that's a good point to bring up the sort of moratorium. Do you guys, so for those who don't know, there was actually a moratorium declared on API changes and language level changes, or?
Language level
changes, at least at the sort of at the language
sort of thing. Do you think it worked? Do you think it was a useful?
Yeah, it basically, for about a year and a half, just settled down a lot of discussions on Python, mainly on Python ideas, and just said, no, we're not going to mess with the core language for the period. I think it gave the other implementations a good chance to catch up to 2.7. It gave us a chance to settle down and look around at the state of 3.1, what was broken in 3.1, improve the Unicode support in the 3.2 standard library. It was just a useful stabilization period in a lot of ways.
Because, I mean, it was quite controversial at the time.
Yeah.
And of course now it's over, so we can get yielding from subgenerators.
Yes. Which, once its test suite is sorted, will go in.
So Raymond looked like he wanted to interject there. No?
Its intended purpose was not to slow down the rate of language development. It had that effect, which was a good effect because the people submitting nutty ideas had kind of gone through the roof at the time the moratorium came around. And so the moratorium helped address the fears of a lot of people who were trying to build systems around Python, who was worried that it was going to change out underneath them. And so it put in some desperately needed sanity, but its real, its announced purpose was to let all the other implementations catch up. Well, by that point, we were already at 2.7. The other implementations were targeting 2.7. PyPy was entirely unaffected by the moratorium because Python 3 stopped changing and they don't care. And Jython was still trying to get Python 2.7 compliant, and IronPython was aiming for the same thing. So in a way, the other implementations didn't actually benefit. The benefit was the side benefit of, Python's got a very interesting atmosphere. We accept these feature requests. We have these very interesting discussions, which communicates to everybody, this is an unfinished, this isn't like C# where you would have to appeal to Microsoft for a change. And so it creates this idea. Anybody can take any nutty idea they have and present it out as if there's a high probability that tomorrow it will get adopted. And on the one hand, we want to encourage that because it lets us progress faster and discuss ideas really well. On the other hand, it scares the snot out of everybody who's actually trying to build a solid system around Python. So this helped us achieve balance. Fair?
Yeah, absolutely.
I think for the alternate implementations, though, the fact that 3.2 is still so close to 2.7
may be helpful.
Means that the delta for them in adopting 3.2 shouldn't be that big.
So now
particularly for ones like IronPython, where the single biggest change is the Unicode switch, and Jython and IronPython, because the JVM and CLR are Unicode native, they already have 16 bits, or they already have Unicode strings anyway. So.
Yeah. So what else can we look forward to then, now that the moratorium has lifted and the insanity resumes?
Yeah. Well, I want to change your question into another question,
yes,
which is, what things can I be doing to help Python 3.3?
That's quite a change, but sure.
Oh, okay. Well, things you could be looking for. Yep. Alan Kay said the best way to predict the future is to invent it.
Yep.
So if you would like to be a co-inventor of the future, the Pretty Print module was knocked out by someone over a weekend 2 decades ago. It's something that met a quick and dirty need. It's not easily extendable, and there's a lot of problems it doesn't solve. We now have many pretty printers. We have one in the XML library. We have a pretty printer in the JSON module, RepRlib. There are some third-party pretty print modules, and pretty print technology has advanced quite a bit. Ruby has a really nice pretty print module. So I'm leading a project if you would like to participate, now is the point where we want to collect the ideas of making a pretty print that's easy to use, that's easily customizable, easily extendable, and incorporates the best features of all of these other tools. The random module has the Mercian Twister, which is a really fine random number generator. But I put that in not quite a decade ago, but it's maybe like 8 years old. And it was mature technology then. Technology has gone forward. So we need our we should have some alternative random number generators. Not take the MT out, we'll leave that in, but give you some more choices, perhaps one based on stream ciphers or whatnot. So if you have expertise in that area, I've opened a feature request for it, and I'm looking for people to participate so that we can make a good addition there.
I see a couple of volunteers over there, yes? Sorry, Ryan. Ryan's got to get off his little feet.
Thanks. I can offer a perspective from SciPy. SciPy used to have 3 plotting modules before Matplotlib was around. And then when Matplotlib surfaced, SciPy removed those. I've heard the sentiment that the Python standard library is where good code goes to die.
Yes.
I'm interested in the sort of process around removing stuff, around breakage. And so there's often a sentiment among core developers that Python 3 is the one chance to fix Python for all.
That's Python 4.
Can I take?
Right.
I've got a lot of opinions on this one, so I'll just jump in on this.
Yeah, sure.
One is a couple of the mistakes I've made and things I've learned over a decade of contributing to the core is it is unlikely that I will ever again suggest deprecating anything major. What I will do is substitute in something new. I say, argparse is better than opparse. So I will mark up the documents for opparse and say, use argparse. But I won't take everyone who has written thousands of lines of code in opparse, and I'm not going to go shoot them in the head, but it's just because I think the argparse is a better way to go. So I prefer to deprecate by way of documentation. So in the pretty print module, I intend to put in a new class, the new pretty printer. I will leave the old one fully alive, and I'm not going to break any of your existing code. And I will just point by. And an example of using documentation is in Python 2.7. If you go to look at the built-ins, you'll see the built-ins are listed in 2 different sections. There is the built-ins, and there's the built-ins you don't need to know anymore. And I moved them to a second page so that you still have documentation for apply and coerce, even though you don't need them anymore. And I forgot the other 2 that we don't need anymore. And so we've used documentation as a way to just say, you don't even have to bother learning these now. But it's still there. And so I'm very much against taking things out.
So then, just maybe because we're about to wrap up, what do you think, what were the big missed opportunities with Python 3? What you know, at what point, when we go to Python 4, you know, when Raymond or someone overthrows Guido's benevolent dictatorship, what were the big missed opportunities? Were there any?
Certainly.
Probably. I'm just kind of thinking of it right now.
There's some methods on the bytes object that could have been removed.
Well, they were added
most of
in
them.
Python 3, right?
In Python 3.
Well, so the thing with the bytes object is one of the things we were struggling with was lots of people still wanted to be able to treat binary data as ASCII text. And so that was the tension in the design of the bytes object, was we were trying to take away the things that made it act like a string, but some people wanted to keep them. And I personally think we erred too far. They're still too string-like. We should have taken more of those methods away. Mm-hmm. But it's too late now. They're there. We're stuck with them.
You shouldn't be able to ask a stream of bytes whether they're uppercase.
Yeah.
Right.
It doesn't make any sense.
No.
But they're still there.
I think the missed opportunity was we started out saying this was our one chance to remove things, and then didn't remove. And so what I would have liked to have done is targeted what are the things that we use the most that make Python really wonderful, and then take everything else and move it toward the rubbish heap. And so ask ourselves, like, we have this line continuation character, but we can also do an open paren for that sort of thing. Do we still want the line continuation character? Do we want so many different ways to make quoted strings and whatnot? And there were probably, what I'd like to do is take a list of all the things that a person has to learn in the first 2 days of learning Python in order to be functional with the language, and look at that list and say, does every one of those things need to be on there? For instance, abstract base classes was thought to be an optional concept, but as we push those throughout the language, at some point it's going to become a day one concept where you won't be able to use the language with it. Decorators were like, oh, that's a more advanced concept. In your intermediate class we'll teach you decorators. Well, now decorators show up everywhere, so you have to learn it on day one. I can't teach a person some Python, not show them decorators, and then turn them out into the world, because right away they'll bump into a wall. we've overused meta classes. There are too many cases where code got implemented with meta classes where we didn't have to, meaning that if somebody's going to modify it in some way, they have to go through a fairly mind-bending exercise there. So we lost the opportunity to shrink the language.
Did you have any sort of last points there, Richard?
But I'm not opinionated on this.
No.
I think you covered off pretty much everything there.
Okay, well, we've got time for one more quick question. If anyone's got one? No?
Wow.
Okay.
Oh, no, there's one for the gallery.
Sorry, I'm not paying attention up upstairs. Yes? You have to yell.
We can repeat the question.
Would you, so in an absolute beginner scenario with your teaching, would all three of you teach Python 3 over 2.7?
Yes.
Yes, I would teach Python 3 over 2.7.
Nick?
I'd have to go back to what Raymond said earlier. It depends why I'm teaching them.
It is so much easier to teach than Python 2.
Okay. Cool. Well, we'll wrap it up there. I think, do any of you guys have an opinion on the best questions?
You were supposed to be keeping track of that.
I was. But I'm also seeing if you had any particularly...
Oh, right. Yes, I liked the teaching.
Yep.
First
that
question
came up a
about
couple of
teaching.
times. I'm going to give one to the person bringing up the fact that C extensions are still a massive pain point.
Yeah, they are.
And what was the question that we answered just before it got asked?
Yes. All right, that'll do. Here, you each, if you can come up and
The
grab
time
a book.
machine question.
The time machine.
Time question. And thanks very much. And these guys and myself will all be around for the conference, so feel free to badge them all.
And Senthil's around as well.
Yes.
So I'll dob him in too.
Yes. Oh, yes. Fair enough. There you go. And thanks very much. And yep, as I say, have a great rest of the conference, guys.
Well done, guys.